This video is going to go along with task sheet 665. This is talking about idle control systems. Again, my truck being a little bit older, I have what's called an idle air control valve. That's how we control the idle speed on this truck. Newer vehicles that have drive-by-wire, you don't have to have that. The PCM can simply command that throttle plate to open or close a little bit to get the desired idle. Versus the older style that have a cable, the PCM can't pull on that cable, so it has a passageway made into the throttle body. And then there's what's called an idle air control valve coming in from the side. It's got a little plunger. PCM moves that plunger in or out, and it either opens up or blocks off that passageway a little bit so we can get a desired amount of air through there to control our idle. I never really had a whole lot of problems with these valves, but every once in a while you may see one. You can have a problem with the valve itself, or a lot of times what would happen is they just get full of crap. They may get all carboned up and everything, not being able to move. So sometimes you just got to take them out and kind of clean all that stuff out. But other than that, you're looking at electrical problems, stuff like that. So the drive-by-wire style, typically those throttle bodies are not serviceable really in any way. So if you have a problem with that system, you just replace the whole throttle body. That's got the throttle body itself, the plate, all the motors and gears, and then there's going to be position sensors in there also. Those throttle bodies have two position sensors in them. One reads low to high and the other one reads high to low, and they kind of go inverted of one another, so that if you have a problem with one, you can pick it up by comparing it to the other one. So that's typically how the PCM picks up problems with those. They want to be in agreement all the time. The same thing, it's got the same setup in your accelerator pedal assembly in the vehicle. So you just have an accelerator pedal bolted to the firewall with some wires going to it. And it's going to have a pair of sensors in there that act the same way. One goes high to low and one goes low to high. So they need to agree, or else it's going to set a code, and we're going to go into what's called reduced engine power, or you may hear it referred to as like a limp home mode. You're not going to get much throttle response. You're not going to go very fast. This is just, it's what the name implies. It's to limp you home, or limp you to a shop, something like that. But we don't want to be giving you a lot of throttle control. If we don't really know where the throttle's at, you don't want to be trying to accelerate just a little bit on the road and all of a sudden you're going like wide open or something like that. So there's a lot of risk for something going wrong if we have a problem with one of those systems, so they kind of lock it down. But I'll show you some things that we can do with the scan tool regarding idle control, and we'll take a look at the circuit overall and go from there. So here we got our throttle body, and right up here on the top, this is our idle air control valve. Down here on the bottom, this is a throttle position sensor. That's another thing we could have an issue with. That's going to report to the PCM where exactly our throttle blade is. So as we go through the range, it's reporting position to the PCM. Cables over here, obviously. This is we're going to have one that's connected to our throttle pedal, accelerator pedal, and then we're going to have the other is connected to cruise control. And if we look, let's see if I can show you guys this. It's kind of hard to get this in there. Those passages up at top are for the idle air control. So in a more modern throttle body that has drive-by-wire, we won't have those extra passages, but that's where our idle air is going through. So that valve will block off or open up that passage, and that's how we get our idle control. This has got a couple screws on the side. They can round off from time to time. They don't always like to come out of there real easy. It's better if there's bolts or anything, but on this particular one, on this particular vehicle, if you wanted to take that out, I'd probably pull this alternator out also, so you can get a straight shot at that back screw. or else you're going to end up tearing it up and have a bigger issue on your hands. I suppose you could maybe pop out the throttle body, but this older one actually has coolant running to it also, so we'd have to deal with that. Typically, if I had to make the choice of dealing with getting cooling system filled back up and air pockets out and all that kind of stuff, I'd rather pull the alternator off. But that's just me. It may work better for you the other way, but that's how I would do it. But I'm going to get this thing started up and show you guys a couple things on Scan Tool. So we've got the truck running. We've got our Scan Tool hooked up. You're going to need to go into a specific vehicle on this instead of using the generic functions of the scanner. So you actually have to go in and tell it what kind of vehicle it is and what engine you have and all that kind of stuff, versus if you hit the generic functions, you're probably not going to have ability to control any of this stuff. If you guys don't know, this is what's called a bidirectional scanner, and what that means is that instead of just reading from the vehicle, we can actually tell it to do things. So if you ever come across that, bidirectional scanner is a better tool to have. You can do more with it versus one that's not. You're just pulling codes and maybe looking at data, but you can't really tell the vehicle to do anything. So we're gonna go into engine. We've already got our cable hooked up. We're going to go into functional tests. This is our functional test menu, and then we're going to go into output controls. So we've got even more things we can do in here. There's quite a few things we can control with this. A bunch of injectors, things like that. We've got our IAC control right here, idle air control. So that's what we're looking for. Here you see fuel trim resets in this menu also. We talked about that yesterday a little bit. We're going to IAC control. So typically when we are in a special function, it's going to give us data that we can look at while we're doing this. So you're not just locked into one screen and not getting any information, because sometimes you need to have control while looking at data. And one of the things I used to do with this a lot is not necessarily using this function for testing the idle system, but if I had another problem, maybe I had a noise that only happened at a certain RPM, or if I'm doing a test that where it wants a sensor value at 1500 or 2500 RPMs or something like that, I can go in with the Scan Tool and command that specific RPM into the vehicle, and I don't have to sit there trying to nail that RPM just with my foot on the gas, because that's not really easy to do. So I would use this a lot in that way. But what we need to do on this particular Scan Tool, we need to hit Start up here at the top. That will allow us control. And then we can raise and lower our RPMs. I don't know if you guys can hear the RPMs on the truck coming up. But if we need sensor data at 1,000 RPMs, we can go and look at our mass airflow, things like that. Really whatever's in this list, and see how we're acting at exactly 1,000 RPMs without having to try and hold that with our foot. You're going to have greater control with a, let's exit out of here. Let's see if that gives us back. No, that's just going to lock us into 1,000. Let's exit out of this completely. You're going to have a little bit better control on a drive-by-wire system, since you can control that throttle plate the entire way, versus this idle air controller. It's only going to be able to do so much, without the throttle plate being open. So you're not going to get as high of a range with a idle air control versus a drive-by-wire system. So we're going to go through a little scenario here, like we got a check engine light, and we'll work through that, and that'll finish us up for this sheet. So I'm trying to figure out exactly what to do for this diagnostic scenario. I kind of ran into some problems. And this is something that you're gonna experience in the field, especially on older stuff like this. I know I keep mentioning that, but any of this is going to depend on where you work and what kind of tools you have access to. So, looking at the flow chart for, I believe it was a PO506, was a idle circuit or idle too low code that I had found. And of course, I got wiring diagrams and stuff like that to go off of. But looking through that chart to do some diagnosis on this circuit, they want you to use a special tool. You're going to run into that a lot, especially if you're in the independent side of the business. You know, if you're working at a Firestone or, you know, a mom and pop shop, that kind of thing, and you're working on a little bit of everything, you're going to go into service information, and a lot of times it's going to ask for a special tool. And a lot of times you're just not going to have access to that. You know, there's some of this stuff, you know, you're not going to be able to buy off the tool truck. But that's what kind of happened here. What the process calls for is to unplug the connector at the idle air control valve, and they want you to hook up what's called a Noid light. And not just any one, it's special for this circuit or for that connector. I have a set of Noid lights for fuel injectors. It's kind of a common thing, and I'll show those here in just a second. But of course, none of mine work with idle air control valve. They're not designed to. So I tried a couple other things to try and, you know, pick up our signal from the PCM, but nothing was really working. So you'll have this problem. I guarantee it. Out in the field, you're gonna have to figure out, you know, how do I figure this out? What do I do without these special tools? And in reality, unfortunately, what happens sometimes is that you can look at the circuit and maybe kind of get an idea of what's wrong. So in this circuit, all we have is the valve itself and the PCM and the wiring. So if we have a problem that's not mechanical, you know, as long as this thing isn't stuck or all carboned up, you know, if we have an electrical problem, we're trying to test this thing. Really, we can test the wires end to end from our harness connector at the valve. We can test it from the valve to the PCM, make sure we don't have any open wires or shorts or anything like that. But going further than that, I mean, we may not be able to come up with anything just because we don't have the right testing equipment. So that puts you in a situation of you have three components that, you know, could have an issue: PCM, wiring, or the valve itself. And you can only, you know, eliminate one of them. So we've eliminated wiring as a cause. So now you're in a situation where, do I have a PCM that's failed, or do I have the valve on the other hand? And just in personal experience, what typically happens is, honestly, I've probably replaced 5 PCMs in, you know, 15 years where it was actually needed. People love to replace PCMs. They get into something where they don't necessarily understand the circuit, or if it's a situation like this, they don't have the tools. They make an assumption, it's got to be the PCM. So they replace it, they bring it to us to the dealer, we program it, and it wouldn't fix it. And it happened all the time. It got to the point where usually if I got a ticket like that that just said reprogram PCM, I'd ask the advisor, you know, do they want to pay me to reprogram this, or you can pay me now and I'll just diagnose the car, you know, correctly, and they can get on their way. And they'd always say, just reprogram the PCM, and it never fixed it. And then they say, well, what do you think it is? So, well, I already offered you that, you know, it's not free. So in this situation, it's going to come down to cost most of the time. That valve is going to be a lot cheaper than a PCM, so I'd start with putting a valve in there and kind of going from there. But if you get in a situation like that, and you know, that's kind of the way it needs to be treated, everybody needs to be aware of what's going on before you proceed. You know, if you think it needs a valve but you're not 100% sure, the advisor needs to know, and the customer needs to know that what they're paying for isn't necessarily a sure thing, because that'll come back and bite you. So if everybody is aware up front, you know, explain the situation, And as long as everybody's aware, usually everybody's cool with it. So I'll show you guys these Noid lights real quick and the wiring diagram, and that'll wrap us up. So this is my Noid light set. These are typically for fuel injectors. We don't really use these a whole lot anymore. Like this big one right here is for throttle body injection. I probably only use 1 or 2 out of this entire set. But this is kind of a universal set. It'll do a whole bunch of stuff. Do some Ford stuff, some Bosch, some GM stuff like that. So what these are is just they're little LEDs with terminals on them. And you plug these into the harness. And then you'll command on the fuel injector, or in our case, the idle air control valve, and these will light up and they'll blink as you're going through the commands. So that's what you're looking for. If you got a blinking light, well then you've got power and ground back to the PCM. You're good. You probably have a component issue. But not being able to use this, we can't get the PCM out of the equation. So unfortunately, that's kind of where it leaves us. Again, these are for fuel injectors. This thing is kind of cool. For if you're doing this by yourself, you need to be in the car with the scan tool. You hook up this Noid light. You put this little rubber booty around there, and this part inside and this whole cable is a fiber optic. So you take this other end and you suction cup it to the windshield, and every time the light blinks, it carries that light down this fiber optic and it blinks up here, so you can see it remotely. So kind of a cool little thing. I probably only use it like that just a very few times, but that's a good set to have around. Like I said, you don't use it necessarily as much as I used to, but depending on what you're working on, this might be something that you need. So I got the wiring diagram pulled up right here, and you guys can pull this up on ALLDATA if you want. For my vehicle, anything newer probably just isn't going to have an idle air control valve, but it's a pretty simple circuit. We've got PCM, and then we've got our valve. There's 4 wires. This is a stepper motor. So what a stepper motor does is it goes in steps. It can go in a little bit. It can go, it goes in and out in multiple positions. So it's not just like on or off. We can get kind of all that mid ground. So that's why it's got a coil that's going to pull and a coil that's going to push. So that's why we want to command with the PCM and watch those Noid lights, because we want to see the command coming out of the PCM. So in this circumstance, what I would do is run out all these wires from end to end. Make sure we don't have any terminal issues. We don't have excessive resistance on any of these wires. There's no other connectors in this circuit, so it's just straight wiring. So we don't have to worry about having an extra connector to deal with in there. But unfortunately, that's really all that we can do in a situation like this. So just trying to give you guys a little bit of insight on what I would do when running across this kind of thing, because like I said, it's going to happen. So you need to be prepared and be able to figure something out. So it's not ideal in the situation or in the context of school, and it's not ideal in when you're out in the field, but it kind of is what it is in this situation. So fill out that task sheet the best that you can, and that will wrap this one up. Thanks.